Today we're going to continue with design patterns. And today I would like to talk a little bit more about a couple of design patterns which can be beneficial to our construction and continuous design of the elevator simulation. So I'm going back to the design pattern presentation. Right, but before we formally jump into any of the topics there, so these are the things that I would like to go over today, time permitting. The first thing I would like to go over, which we have already seen in our Java class, is the iterator. Right. So the iterator design pattern, and let me just write more clear, iterator. Okay, so iterator design pattern presumes that you have a collection of elements, right? And very often you have an object, right? You have an object in memory which essentially holds a list or sequence or collection of other objects, right? So we can have these objects that we want to hold on to. For instance, they could be strings, they could be, anything you want. And there is this collection, a very typical example of this collection, of course, is array list, right? Array list in Java, which is an array list of some sort of element, right? Element over here, and these are individual instances of the element right here. And the collection simply holds references, right? It stores references to these objects. In fact, in Java, you cannot have collection of primitive data types. The only type of generic collection that you can have is a collection that wraps references to these objects, but the collections are generic. So today you can be using one element, tomorrow you can be using different, and you can combine them together. Okay, so then it's very typical for us to write code like this. Oftentimes you can say, all right, then you want to visit. You want to navigate through these individual elements. So you say for element E in my collection of elements, right? Elements. Supposedly that the name of this collection is elements, right? Elements. In this collection, just do whatever you want with element E, right? You can say E do something. Right, do something, and you can this way. This type of loop guarantees that you visit every single element in this collection. Right, you can, under certain conditions, basically break out of this loop by issuing a break statement, right, inside the loop. But for the most of the code like this in a for loop like this, which visits each element inside the collection, you just want to do something uniform to every element, right? For instance, those could be graphical shapes which you would like to move, display, update, hide, unhide, and so forth. Uniform operations on uniform collection of elements. But here's a slightly different situation. Okay, so here's the situation slightly different. In one situation, what if you want to basically have the same of, in fact, let me get rid of get it back, right, and demonstrate this other possibility, that sometimes you want sometimes what you need to do is that you need to remove you need to say elements, right? Elements, and you want to remove or delete this element. Unfortunately, this type of loop, which like for each element in the collection, does not permit that, right? So it basically says you cannot do mutating operations on your collection in this situation. Here's another example where this type of loop will not allow you to do the work. In the second situation, I'll just try demonstrating it. That you may have another collection, right? You may have another collection over here, right? And you can have other, type of things over here, like other elements, a different type of collection over here. Okay, 1, 2, 3, 4 elements in this one that I use, right? And so maybe as you visit each element, perhaps you also want to, perhaps what you want to do is that you want to advance by visiting this element and this element, and then this element and this element. But that for each structure, that type of loop, would permit you to iterate only through one single collection, right? You can't really make adjustments, make your progress in a different collection. So if you have to, in parallel, iterate through two different collections, that idea will break. So then what you can do is, that you can then basically try writing a loop like this, right? Another type of loop that you can write in that situation would be for, some sort of integer index, right? Use index access. Index equals, 0 to begin with. Then you say index is less than my, elements dot size, and then you say plus index, and you can then use this index inside your loop, right? You rely on index to get to everything. And so internally you can write another program that uses another index, which iterates through a second collection. And so you can make basically progress through both of these collections using essentially calculating an index which will allow you to access elements in both collections. So this is possible. However, the code gets real messy because you have to deal with more than one, with more than one instances of variables that potentially control your loops, and also there may be non-uniform collections in terms of with different number of elements. So there's all kinds of challenges. All kinds of challenges exist in this situation. So the alternative to use these nested loops with indices, you can say that maybe I could have a helper object, okay? Just another type of object, a helper object, okay, which remembers two things. First thing, it remembers the address of our collection in memory, right? So basically, when we create it, we need to give it our original array list. And second thing that it can remember is the position, right? Basically, say that, for instance, we can start at the beginning of this collection, and we may be able to basically navigate forward to the next element, and to the next element, and to the next element. And so instead of holding on to these indices that we index 1, index 2, if we need to access another collection, we can have helper iterator objects like this. Like these helper objects are called iterator objects, which allow us to navigate through the collection and basically use object-oriented style to access individual elements. So let me actually demonstrate this in the code. It really is a very short demonstration if you'd like to see the demonstration. And there's nothing new. Like I said, we briefly talked about the iterators in our Java class. So let's just do the demonstration now.